Welcome to the Rich Report, a podcast with news and information on the world of big data. Today, my guest is from the Transaction Processing Council. We have Michael Poess. He is the chairman of the TBCTC committee for the Transaction Processing Council. So, Michael, welcome to the show today.
Thank you very much for having me.
Well, great. I'm glad you could join us. I wanted to understand, the changes that are going on and reacting to the industry here. So why don't you go through your slides, and then we'll follow that with a Q&A.
Great. So my slide deck consists of three portions. One is about the TPC, then one about TBCTC, and I will not spend very much time on the first one, a little bit more on the second, and the most I will talk about is the third portion, which is about TBCDS. I'll give, again, a short background on the mission and background on the TPC, then TBCTC, Technology Conference Overview, Call for Papers. I'll spend a little bit more time on that one, on the Call for Papers, because people might be interested in what the TPC is looking for in terms of papers. And then the main portion is TBCDS, the new benchmark from the TPC. Let's move to slide 3. The mission of the TPC, it's a nonprofit corporation founded to define transaction processing benchmarks and to disseminate objective, verifiable performance data to the industry. It's been around for a while, since '88. We have currently 4 benchmarks, TBCC and TBCE, which are online transaction processing benchmarks, and TBCH and TBCDS, which are decision support benchmarks. H has been around for a while, and DS just got voted in this year. In addition to these benchmark specifications, the TPC also has specifications that are consistent across benchmarks to make it consistent, how energy is measured and how the systems are priced. So I'm going to step over 4. Let's go to 5. The TBCTC, which is the technology conference the TPC organizes once a year. Let's go to this year. We will be co-located with VLDB on August 27, 2012 in Istanbul, Turkey. We've had this conference, now switching to slide 6, already 3 times. First time was in France, in Lyon. The second one was in Singapore. The third one was in Seattle. And again, this year's conference will be held in Istanbul, Turkey. Let's go to slide 7. The TBCTC is open to industry experts, researchers, and vendors, and of course customers. And we co-located with a very large conference on databases, VLDB. The acronym is Very Large Database. And we have a very interesting person as a keynote speaker this year, Michael Carey, from the University of California at Irvine. Going to slide 8. Let me spend a little bit of time on this one, because this is the call for paper. So we solicit papers from industry experts, academia, and also customers if they have good stories that they want to share with us, how they're using systems, how they are using benchmarks to make decisions. And the topics that we are interested in, and we don't always cover all of these topics, but that we're interested in is are listed here as big data, cloud computing, social media infrastructure, business intelligence, and so on. Don't want to name all of these, but these are the main topics that we are interested in. And we usually get 3 times as many papers as we can accommodate in the conference. So we have a peer-to-peer review process where we select the top third, and they will be in the authors of these papers will be invited to the conference to present their papers, and the papers will also be published in the Springer's lecture notes on computer science. It's a book that is available in print and also online. And the TPC uses these papers to get an insight into what other people think about benchmarking, about the TPC. And in the past, we have also used this forum to incorporate new ideas into the TPC. So there's a feedback directly into the TPC. An ETL effort, virtualization effort, came from papers presented at the TBCTC. So it's a very important part of the TPC. Now let's move to slide 9, which is the beginning of my presentation about TPC-DS. Let's go to slide 10. So the benefits of TPC-DS is that it's designed to be widely used by vendors to demonstrate their capabilities to support complex decision support systems, used by customers as a key factor in purchasing servers and software, and by the database community for research and development of database and system optimization techniques. And in the past, TPCH, which was the precursor to DS, has been widely used in academia to test research results. And TPC-DS is intended to provide a fair and honest comparison of various vendor implementations by providing highly comparable, controlled, and repeatable tasks in evaluating the performance of decision support systems. Let's move to slide 11. There's a very strong customer demand for a carefully designed benchmark that measures performance of a given hardware configuration, an operating system, a database management system configuration under a controlled, complex decision support workload that's comprising of a single user performance, which we call a power test, which measures the system's ability to get the answer to a single query very quickly, then a multi-user performance, which we call a throughput test, which demonstrate the system's ability to accommodate multiple users and to get the maximum throughput. And the third one is continuous data integration, which is an ETL workload that takes data from an OLTP system or a bunch of OLTP systems and continuously feed the data warehouse to be up to speed with the information that's available from the field. TPC-D and its successor TPC-H have been around for a long time, for 18 years now. DS does not substitute H. DS intends to extend TPC's benchmark portfolio with another data warehouse benchmark. Let's move to slide 12. So DS addresses most of the changes in data warehouse design that happened over the last 20 years, I would say. So H was all about a normalized schema. Now we are into denormalization. In H we had small data sets. In DS we go for a very large data set of 99 queries, and I'll go into the details later. The queries are very complex, including tool-generated queries. The queries use modern SQL constructs. That means we're using SQL 99 plus OLAP extensions, so roll up, group, complex group by, so on. We include a database-centric data integration process. And very important, we included a continuous data integration, what we also refer to as trickle updates. And we also incorporated ad hoc and reporting queries into the same benchmark, which is also very tricky. And DS also solves a lot of database engineering challenges, how to benchmark these things. how to have a realistic table content, for instance, or realistic table scaling, non-uniform data, which is easy to say, but for a benchmark which needs to put a predictive, repeatable workload on a system, that's a little tricky. And the inclusion of null values, which is also not trivial. Let's move to slide 13. The TPC's philosophy of benchmark business models is such that a customer should relate to them. And they should be such that the customers relate the business to the benchmark business model. They relate their workload to the workload of the benchmark so that they understand the benchmark. Let's move to slide 14. So TBCTC business model is about a retailer that must manage large number of products, that must sell products through various lines of business nationwide. And the lines of business are the traditional ones: store sales, which comprise of 50% of all sales in the benchmark; catalog sales, which amount to 30% of all the sales on the benchmark; and web sales, which are 20% of the total sales. It also includes inventory tracking and shipment from warehouses. Let's move to slide 15. So the business functions that are modeled are the typical business functions of such a retailer: sales, inventory, shipping, planning, marketing, fraud analysis, and customer analysis for marketing purposes also. Let's move to slide 16. Here are just a few examples of what business questions are answered in the benchmark. For instance, fraud detection is find customers who have returned items that they bought from a catalog 20% more than the average of those items in a given state, in a given time period, or identify prime states, list all states with at least 10 customers who during a given month bought items with a price tag at least 20% higher than the average price of items in the same category, or queries that identify repurchases, analyze for each state all items that were sold in stores in a particular quarter and returned in the next 3 quarters, and then repurchased by the customer through the catalog channel in the 3 following quarters. These are just example. Overall, we have 99 of those business questions. Let's move to slide 17. This gives a very high-level overview of how the benchmark is executed. We have on the left side the raw data, in the middle the data warehouse, and on the right we have queries. So this shows how the benchmark transforms raw data into a data warehouse to get to information. And we have 2 sources of raw data. One are simple source files whose structure is similar to that of a data warehouse, and we use that in the initial load. And that can be seen as initial load or a periodic load, reload of the entire data warehouse. That's why we have the same structure in the source files as we have in the data warehouse. Secondly, we have files from OLTP sources, which are fictitious. We are not modeling those, but we have the data extract from those sources. And those don't correspond in structure with the data warehouse, so there need to be transformations coming from those files into the data warehouse. And of course, this is an ETL kind of process, and we have enhanced it with a model to continuous data integration, meaning while we're running queries, we are updating the data warehouse. And of course, the data warehouse, we run queries against the data warehouse, and there are different kinds of queries. Some are reporting kind of queries, and I'll go into that a little more. OLAP queries, data mining queries, and ad hoc queries. I mentioned ad hoc and reporting before because ad hoc and reporting are kind of contradictory, because for reporting one needs auxiliary data structures that facilitate these reports, versus ad hoc is is no auxiliary data structures where the system needs to react very quickly on a query that it hasn't seen before. Let's move to 18. The schema that we use in DS are multiple snowflake schemas. So we call it a snowstorm schema. Of course, it's denormalized. We have 26 tables, 7 fact tables, and 19 dimension tables. Tables are very wide, 30-plus columns. They have diverse data types. They have a very wide range of cardinalities. And basic auxiliary data structures are allowed on all tables. And by basic auxiliary data structures, I mean indexes and maybe foreign key primary key constraints, which translates into indexes in most cases. And complex data structures are only allowed on the catalog sales channel. So that is materialized views, bitmap indexes, join indexes are only allowed on catalog sales, on the catalog sales channels, which is a subset of the entire schema. As you can see down here, we have a catalog, the 2 catalog fact tables, returns and sales, similar web and store, and inventory in between. Let's move to slide 19. That is the star of the store fact tables. You can see the fact table in the middle and the dimensions outside, which is very standard. If you click one more time, you see how the store returns hook into the structure. Most of the dimensions are shared with the store sales, and if you expand that, I don't want to do that because it will blow up the picture, but the catalog sales and catalog returns and web all share most dimensions. They introduce some more, but it's the same picture, just more complicated. Let's move to slide 20. In DS, we put a lot of emphasis on the data set. So we have real-world content for street names, city, and so on. We included null values. We introduced a data skew, which is very important to, first of all, make the benchmark realistic, but also put stress on the query optimizer to get the right query planes for the queries. So for instance, we have a sales pattern which kind of resembles a sales pattern of a typical company. Low sales between January and July, medium sales between August and October, and then higher sales in November and December. Similarly, for colors, we have colors, group the colors in low, medium, and high likelihood, just to get a skewed distribution. Let's move to slide 21. As I said, this is about data sizes, so table cardinalities. We have a very wide range of database sizes, ranging from 100 gigabyte to 100 terabyte. We have realistic table scaling, so we have linear scaling of the fact tables and sublinear scaling of the dimension tables, and we have some static tables that don't scale at all. And I say realistic because in H, everything was scaled linearly, which at one point becomes very unrealistic because you have too many items or too many customers compared to the sales. The queries are also very realistic. They use real business questions. As I showed earlier, we use SQL 99 plus OLAP extensions. And we have 99 query templates from which we can generate an almost infinite number of queries, which use many table joins, large group by operations, large aggregations, large sort by operations, many analytical functions. Some are I/O intensive, some are CPU intensive. So we have a very broad mix from a technical perspective. Now let's move to slide 22. We have also, as I said earlier, a source schema. I don't want to go into very detail, but it is one is the schema that loads the initial data warehouse, and then for the ETL process, we have a normalized kind of schema where we apply ETL transformations to load into the denormalized data warehouse. And they vary from simple to very complex. And the complex ones, they involve feeding into history-keeping dimensions, which is very tricky because it does not always involve reading the data, transforming it, and loading it, but also to query the data warehouse to get certain data to get the latest record. Let's go to slide 23. So this is a complex slide. It basically shows the flow of the benchmark from the beginning to the end and how the metric, which everybody is interested in reading about the benchmark. The TPC's philosophy is to have one metric. So the metric incorporates a lot of aspects from the system being tested. And it starts with choosing a scale factor, which represents the data size. So that is the SF on the left side, slide 23. And by choosing a number of users, which is shown on the left-hand side as well under scale factor, and it's S. With that, a lot is already determined on how to run the benchmark. The initial phase is the database load test. And it means to take the data, which is in flat files, which have the same structure as the data warehouse, and load them directly into the data warehouse. The time it takes is recorded as the T-load time. And it includes the data load, building of auxiliary data structures, and performing data analysis on top of the loaded data. The next test is the power test, which has to start right after the database load test. And the power test is the execution of 99 queries, one after the other, simulating a single user. And the queries are here represented by the little dots. The time this takes is recorded as T power. The next test, which follows immediately after the power test, is the first throughput test. And in the throughput test, we execute S streams of 99 queries. And the S streams represent S concurrent users. Queries, of course, are executed in different orders, or different permutations, and they are also slightly different. So user 1 does not execute the same queries as user 2, and so on. Most importantly, at the same time, we are executing refresh functions, and these are resemble the ETL portion of the benchmark, so the contiguous data integration portion. And they're trickled into the execution of the query streams. And the benchmark is constructed that one cannot fool the system. They really have to be concurrent with the queries that are executed on the system. And the time that this takes is recorded as T throughput 1. The last phase of the benchmark is the second throughput test, which is a repetition of the first test, the first throughput test. So there's nothing new except that it's run with different refresh data, but the same queries are executed with the same number of users. So now we have 4 numbers. We have T-load, T-power, T-throughput 1, and T-throughput 2, plus we have scale factor and the number of concurrent users. How do those numbers get feed into the metric? And I will show that now. So the metric in DS is called QPH-DS, query per hour DS, at a certain scale factor, because if you choose a different scale factor, different database size gives a different result. And in the numerator, we have scale factor times query. In the denominator, we have three different portions: TLD, TPT, and TTT. And how we calculate these is by TLD is basically the load time. However, we didn't want, since the load time can be very long, we didn't want to overload the metric with the load time, so we adjust the load time by accounting for the number of streams we run and by multiplying it by 1%. And 1% is more an arbitrary number, small enough so that the load time doesn't overwhelm the metric, large enough so it has an impact. Then TPT is calculated as the time it took to run the power test, time S. And the reason for the S is we also wanted the power test to have an equal significance in the metric as the throughput test. That's why we multiply it by S. Then the TT is very easy. It's just the sum of the first test and the second throughput test. Now SF times Q. So SF is the scale factor, and Q is the total number of queries run, which is 3 times S times 99. 99 is the number of queries per stream. Okay, let's move to the next slide. The next couple of slides are just a comparison between H and DS in the various areas of schema queries. So I don't want to go into very details. It just lists, and a lot of these things I've already said about normalized schema versus non-normalized schema and so on. So I don't really want to list all of these, but it gives a nice overview of where the differences are. Now I'm moving to slide 25, which is about the difference in queries, 22 queries in H versus 99 queries in DS. Moving to slide 26, which talks about the updates. Actually, something I haven't said before is H only updates 2 tables out of 8, and DS updates 22 tables out of 26, which is a very significant difference because in H only a relatively small portion of the columns were updated versus in DS almost everything is updated. That brings me to slide 27 and questions and answers.
Okay, well, thanks for that, Michael. You know, I was curious about, you know, the conference that you were talking about earlier. You know, you mentioned a number of topics that are covered, but do they also sit around and talk about how to do better on the benchmark, like cheating, for example?
No.
Okay.
No. That is something that we don't. We haven't had that yet. I don't think we would discourage people from doing that, but I think if somebody found something out, I think they would keep it to themselves and not share it with a lot of people. That would be my guess.
Right, right. And then my other question was about, you had that interesting fraud detection question as part of one of the benchmarks there. And it was very inclusive. It was about, you know, look in this state for this anomaly and that. Is that query, is that expressed in a big complex Boolean kind of way, or is there different ways that you know, a prospective benchmarker would approach that?
Yeah, that's actually done in a very complex query, and a lot of the DS queries are very complex, spanning probably more lines than the average user would write. And we did that on purpose because we wanted to have a mix of simple queries and very complex queries, and in addition to that, also tool-generated queries, which tend to be very long in terms of number of lines and also very structured. So we have queries, you know, simple queries that the average user would send to the system, queries that an analyst would send to the system, like a fraud detector, and then tool-generated queries. And I did not include sample queries in the slide deck. but they are all in the specification. So if somebody's interested, can just look it up there.
Sure, sure. And so, as you roll out these advancements in the Transaction Processing Performance Council, does it become more difficult for an end consumer to tell which is better as you add dimensions to the test?
That is a very good question. But if I look at what happened in DS, and DS kind of built on Age in a way that the same people, a lot of the same people that developed Age developed DS. They learned from what is missing in Age, what is not perfect in Age, and they added on what you call dimensions to the benchmark, like in the schema, like null values or non-uniform data distribution, and then in the ETL process, more complex transformations, trickle updates, and so on. Yes, they make the benchmark more complicated, but they make the benchmark also more realistic. And I think people see today they have non-uniform data. They have to face complicated transformations to get the data from their OLTP systems into a data warehouse. So yes, it's complicated, but I think it's a value add, and people do understand.
Sure, sure. Well, Michael, I want to thank you once again for coming on the show today.
Thank you very much for having me.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of big data.